Alright, this is the video tutorial, we could say, for the Unit 2 practice problems for the final exam. And so as we go through this, you would want to make sure you have your formula sheet as well as a calculator available. So pause me if necessary and make that happen. Okay, LT2, calculate net force. Remember, net means combination of all forces. When we're looking at net force, some things to remember. If they act in the same direction, forces that are in the same direction, we add them. Forces that are in opposite directions, we subtract. Okay? Those are some important things to remember as we go through here. Let's see if I can focus in this in at all. Alright, so what it says is what's the magnitude and direction of the net force in situation. So A, B, C, and D. So what we do, this is a free body diagram. We've got a normal force up at 3. Gravitational force is acting down at 3. So we just look at kind of each side one at a time. So look at the up and down forces and then look at the left and right forces. So 3 up, 3 down, that cancels out. We have an applied force of 5 to the right. A frictional force of 5 to the left means that there is 0 net force acting on that. Okay, 0 newtons. And as newtons, that's not the word on. So this thing is either at rest or it's moving at a constant velocity. Okay, we don't know what. All we know is it's not changing its motion because there's no net force acting on it. We go to B, 3 up, 3 down, cancel out. Force of friction is 5 to the left. There is nothing over here. So therefore, there's nothing to cancel this out, which means the net force is 5 newtons left. Situation C, we have 20 up for the support force, the normal force, 20 down for the force of gravity. There's nothing left and right, so therefore there is no net force acting, because 20 minus 20 is 0. Situation D, we have air drag pushing up on this. We have gravity pulling down. Okay, but if we look here, it's 40 newtons up and only 25 down. So we would want to subtract those. 40 subtract 25, which is going to be 15. And then we have to decide, okay, well, which is greater? That's a bigger number. Therefore, the motion would be up. So 15 newtons up. As we move through here, we have a new diagram. To find the weight of the object in the figure above, remember weight is going to be downward forces. And we have 2 downward forces, F grav, F weight, same idea. And since they act in the same direction, we would add them. So 15 newtons is the weight. Alright. Number 3 refers to that previous picture. So what is the net force in the image above? I just had to copy on the next page here. We have 15 down. We have 15 up. They would cancel out. We have 8 to the left. We have 8 to the right. Those would also cancel out. So there is 0 net force. There we go. Alright, so those are the simplest of problems from that unit. Now, the primary focus is Newton's second law. Remember that said that a greater force creates more acceleration on an object, while a bigger mass resists acceleration. That was more of an inverse relationship. On your formula sheets, remember I wrote it out lots of different ways. If it's force, you're just going mass multiplied by acceleration. If it's mass, it's force divided by acceleration. If you're looking for acceleration, it's force divided by mass. I'm going to start with easier ones, so we're going to skip these first 3. We'll start with just a more simple version. Number 7 says calculate the acceleration. So here's A, that's what we're looking for. By placing we have a 40 newton force. Anytime we see newtons, we know that's F. Kilograms is always mass. So we want the acceleration. If you put a 40 newton force on a 6 kilogram object, we're looking for acceleration when we have a force and a mass. This isn't something where we're looking at change in velocity, so it's a different way to find acceleration. So for acceleration is force divided by mass, then it's going to be 40 divided by 6. I'll give you a second to do that. 40 divided by 6. And we should end up with this. And it's around to the 10th situation, which means we need this place value here. But this one tells us what to do with it. Since it's 5 or above, our final answer is 6.7. Technically, it's meters per second squared, but we know that in Moodle, we just type in the 6.7. Number 8 says calculate the mass of an object. So we're looking for m. We have a force of 50 newtons. We have an acceleration of 3. So this time we go to our formula sheet. Mass equals force divided by acceleration. So it's going to be 50 divided by 3. So again, give you a second to type that in. This time, again, round to the 10th. Same type of rounding scenario. This 6 tells us that we must round the 10th to a 7. So our final answer is 16.7, and since it's mass, it's kilograms, but again, we just type in the 16.7. Number 9, calculate net force, which is F. We have an object whose mass is 6. Acceleration is 1,000. Force equals mass multiplied by acceleration. Therefore, force equals 6 multiplied by 1,000. Probably don't need a calculator. 6,000 newtons. And then one more force one here, looking for force. Mass is 3. Acceleration is 900. Same formula, force equals mass times acceleration. So it's going to be 3 multiplied by 900, which is what, 2,700 newtons. Alright, so these are the easy ones, okay? Pretty straightforward, follow a formula. Now we're going to go back to 4, 5, and 6, because these are more of the thinking type problems. We know that if you increase the force, we increase acceleration. Okay, that's just a thinking thing. We know that if we have more mass, that creates less acceleration. It's harder to accelerate something. So we've got a sled accelerating at a rate of 4. I'm going to write that down. Okay, we're accelerating at 4 meters per second squared. If the net force is cut in half and the mass stays the same, what's the new acceleration? The only thing that changes in this case is the force. So if we pull with less force, we're going to slow down. Pull with more force, we would speed up. We could just do the other side of the coin here. Less force, less acceleration. Less mass, more acceleration. So if we're going to say, okay, it started at 4, but then we're going to cut it in half, then our new acceleration is 2 meters per second every second, because we're pulling less hard. Okay, so it's just a thought process. Oops. So number 5, a sled's accelerating at 24. That's our original. Net force is cut in half. Mass is also cut in half. What's the new acceleration? Step by step here. Net force is cut in half. If I pull less hard, my acceleration goes down. So if I pull by a factor of 2 less, half, right? Factor of 2. I'm going to divide it by 2. I'm at 12. But the mass is also cut in half. So if you are hauling 2 people in a sled and somebody bails out, right, all of a sudden it's easier to pull it. So if we have less mass, and by a factor of 2, we would have more acceleration by a factor of 2. So we would take this 12 and then immediately multiply it by 2 again, which takes us back to that original 24. Okay, because we pulled less hard, but it was also less mass, less weight in the sled. Last one here, number 6, starting at 24. The net force is doubled. We're going to pull twice as hard. I'm going to pull twice as hard. I'm going to multiply it by 2 because I'm going to go faster. So I'm currently at 48. But the trouble is the mass also went up by 2. So I'm pulling harder, but I'm pulling on something heavier. So if mass goes up, acceleration goes down at the same rate. Divided by 2, we end right up back at 24. All right, so those are the types of problems you would see on the final exam from Unit 2. Good luck.